If a small magnet is dropped towards the conducting loop, so what will happen? As it is away from the conducting loop, so the less number of lines are passing through it. But when it is coming close, as you see in the second diagram, so the more lines will cross this conducting loop, flux will increase, and you have to identify which one of these are the correct EMF versus time graph. So as you see that as it is falling down, what is happening? Change of flux is positive because flux is changing. And according to Faraday's law of electromagnetic induction, negative N delta phi over delta T. So EMF should be negative. But remember, this is the increasing negative. Why? Because as the flux is increasing, current is produced in this conducting loop and that current is increasing. So this EMF is negative means that the current will flow in the coil in such a way that it will oppose the coming magnet, the falling magnet. It will try to push the falling magnet. So for example, it should flow in the counterclockwise direction because then it could face north. The magnetic field of the induced current will have a north on the upper side, which means that current should flow in this conductor counterclockwise, which is in this direction, because in that case the north will face the north and it will repel and this current is increasing. So it means in the start current was 0 and EMF was 0, so it is not possible. So now imagine this magnet is leaving the conductor, which means that now the number of lines which were crossing the conducting loop will start decreasing, and we can say that the flux change of flux will be negative. So EMF should be negative n into negative delta phi over delta t. It is making it positive. So you see this, the EMF has changed its polarity. EMF has changed its sign, which means that the current has to move in now in the opposite direction, which is now clockwise. So it means that this option is wrong because they are not showing the current in the opposite direction, and current will change its direction only once, so it will not become positive twice. This is also wrong. So this is the right answer because you see this positive current is showing in a one direction and the negative current means that the magnet is leaving the conducting loop. So the right answer of this question is option C.